Okay, so now I'm going to show you one more examples here, easier one. But before that, let me make it clear what we need to get in the end if we are trying to make a proof by using mathematical inductions. So as you see the model here, this is the model that we would like to prove next. And in the mathematical inductions, I mentioned there will be 3 steps. Step 1, prove for nth equal to 1. Step 2, assume it is true for nth equal to k. And after assumption, step 3, we prove it is also true for n equal to k plus 1. So prove here, assume here, and last one, prove here. So if you look at the model now, the final model over here, we must reach to k plus 1 minus 1. You see the nth here change become k plus 1. The same things also must happen to the other side. N over 2 times 2n, this also must change become k plus 1 over 2, because n change to k plus 1, and the one inside bracket also must change become 2 k plus 1, like this. You see, so the n here change to k plus 1, the nth here change to k plus 1, like that. So our final answer will be this form. Okay, so let's do this. So step 1, prove for n equal to 1. So for n equal to 1, we get the left side is 1 exactly, because here is u1, here is u2. Or you can take directly the number from there, or also you can make use the formula over here from 2n minus 1. Okay, so we get left side equal to 1. Then on the right side, we have the formula n over 2 times 2n. So for the right side, n over 2 times 2n. So for n equal to 1, we got 1 over 2, 2 times 1, which 1 over 2 times 2, and it is 1 again. So now we can see that the right side 1 and the left side 1 and the right side also 1 is the same value, so it is true. Now in step 2, what we need to do is just to assume is also true for n equal to k. So when n equal to k, this is what we have: 1 plus 3 plus 5 plus all up to 2k minus 1. Yeah, 2k minus 1. Assume it is true, equal to k over 2 times 2k. Yeah, all n now change to k. Okay, again repeat. N equal to 1, step 1. Proof already done. N equal to k, assume. So we assume that this model true. We assume it is true. Now the last part, step 3, since we done on step 2, we said it is true, we assume it is true. So we want to show that it's also true for n equal to k plus 1. Let me highlight again. From here, u1, sorry, can't really see. From here, u1, up to this point here, un. This is n equal to k. So when we would like to prove for n equal to k plus 1, meaning there will be another terms after this point. So that will be uk plus 1. But we doesn't need to write it up down. Okay, again remember our goal is here to have this form, our goal. Alright, so continue. For n equal to k plus 1, this is what we have: 1 plus 3 plus 5 per all up to k minus 1. This is up to n equal to k. So the next term will be k plus 1. So we are going to have 2 k plus 1 minus 1. So this is uk plus 1. This one uk. Okay. So based on step 2, we already said that this up to uk here is true, according to our assumption, is true equal to the other side here. So this form here we said is true equal to this one. So we write it down: k over 2 times 2k. So plus the k plus 1, the k plus 1 here. So we put plus 2 k plus 1 minus 1. Okay, so now we are going to manipulate this in order we can get our goal here. Let me just bring it down so that will be easy for us to refer this one. Okay, so let's manipulate this. So we have k over 2, 2k plus, I'm going to manipulate this side first. Over here I have 2k, with this one I have plus 2, and the last one here minus 1, equal to, so this part I will just write it out first, don't do anything yet. Then this one we have 2k, and then plus 2 minus 1 we have plus 1. Alright, so now over here get 2k, over here get 2k, but we not yet can do anything else. What we can do right now, we can change to using the division. Okay, so that all will have the over 2 one. Okay, so I will put this way, over 2 here. So the first term, this one, will have k 2k plus this one will become 4k, this one will become plus 2. So I hope you can figure out that part. Alright, so now continue. So if I multiply this part, k with 2k, so over 2, okay, so I'm going to have 2k square plus 4k plus 2. Correct, yeah? And next I'm going to factorize the polynomial, become 2k with k. So I believe that must be 2 here, 1 here. So if we multiply this, we're going to have the same. Okay. So next, I have 2. Then this part I will manipulate a little bit. So I'm going to have 2k plus 1. Okay. Plus, sorry, I will take out the 2 first. K plus 1. Great. If you multiply inside, you get 2k plus 2 also. And the other part is k plus 1. Got it? I will show it to you here. If you multiply this, you get 2k. Same with above. If you multiply this, you get 2 times 1, you get 2 over there. So it's same as at above. Now continue. We're almost there. So I have now k plus 1 here, k plus 1 here. So can take out the k plus 1. Okay, can take out the k plus 1. So k plus 1 over 2. Then hold on, yeah. Let me see first. 2k square. I'm trying to. Oh yeah, it's already. Sorry. So the k plus 1 I put in front, and over here I have k plus 1. Just make it the same as the goal. So again, we already done it here. Complete. And look at the goal. This is the goal over here. It's the same. Okay. Can you figure it? If not, then let me know. Perhaps I can do another examples. But if you can get it already, it's good. Meaning not to say that this is easy, but you can follow. Again, if you still cannot figure what we are trying to do in here, let me know, especially before you attempt the quiz. As I said, this is the final topic prior to the final examinations, and this topic also will be included in the final exam. So before you attempt the quiz, if this is good enough, then you may proceed to the quiz. If it is not yet, let me know. So perhaps I can do one more examples. But if all okay, then it's good. Okay, so that's all for today. It's a short topic to discuss, but you are going to have quiz after this one. Before that also, I would like to remind you again that I already uploaded the assignment 2, as I mentioned in the group. You can find it out on your LMS here, all the details. So the submissions will be on the 18th July. If I'm not mistaken, that will be on Saturday. So submit the soft copy before 5 p.m. and then the hard copy also you must submit before 5 p.m. put in my pigeonhole. Alright. So once you submit, the following week I'm going to review the assignment 2 so that you can see all the solutions over there. And I'm not sure whether you realize, or maybe some of you knowing it already, in the LMS Actually, I already uploaded two things here. The first one, you see the Discrete Mathematics Sound 3rd edition. From this book, you can download it, and then you can see inside there are so many examples, questions complete with solutions, also questions without any solution for your practice. But you can see there are so many in there that you can make use for your practice. Also, the last one here is I put bank questions for practice only. So this is also bank questions. Here is all the paper or final exam from the previous semesters. So if you go through all, you will see how I made up the question for the final exams, and it's also good for you to practice. Okay, so I advise you to just try to work on and then see later on how. If any problem or questions inside that you cannot do, let me know. All right. Also, there is not only few questions that you might see we never have it in the class. That's okay. That part will not be included in the final exam. So for your final exam, the topic will be all what we have in the class. Beyond that, it will not be included. The topic, I mentioned the topics, yeah? Okay, so there are two here. The Discrete Mathematics Sound 3rd edition is a book for you to show many examples inside. Also the bank question for you to practice. Alright, so I guess that's all. After this, you may attempt the quiz, and then the review for the the review for the assignment I will do by next week. If you need to do another offline class or face-to-face session to discuss, or if you have any questions, do let me know early, so I will arrange the time. And if no more, then I guess that's all. So there will be no more classes after next week. Next week we still have review for the assignment, but after that, then there will be no more classes prior to the final examinations. So I'm waiting for you. If there is anything that you would like to discuss on the face-to-face session, do let me know. Alright, so that's all for today class, and see you around. Thank you for watching.